as described in the readings, calculating a watershed is a multi-step process that begins with filling a DEM and then doing various flow calculations. So in our toolbox, most of these tools are in the hydrology under the spatial analyst tool set, and you start with fill. We're going to fill our driftless DEM, the 3-meter DEM we've been using, specifying an output. And the fill then calculates low areas and fills them. And we can see where they are by subtracting the original DEM from the filled DEM. And here we'll color these so we can see the areas that are filled. Now we're going to classify these in the symbology and pick ones that are just a tiny bit bigger than 0 and give those no color, and then give all the ones that are larger than that a color so we can see through the non-filled to the filled. Now if we load here an image background, we can see that these fills are typically in areas where you have either just small errors or where things like a road occurs and the LiDAR that made this DEM calculated the elevation is higher than it really is. Now there are some areas that get filled and that we have to fill, little dams or little ponds, if we want our watershed to be all inclusive, and we just accept those errors, realizing that the fill papers these things over, these flat areas on the landscape. But most of the fills are either small areas, those single pixels, or things like where there's a culvert, as we can see here, that isn't identified by our DEM. Here the stream continues through this culvert under the road, but the DEM measured this at the top of the road and thinks there's a little dam. So to get the proper watershed and all the flow direction and all that stuff, we have to fill our DEM first, or breach. But once we fill, do flow direction, flow accumulation, and snap pour points. So starting with the flow direction, as described in the book, this calculates the directional flow from each cell to each adjacent cell and gives you these 8 different flow directions here. And then you can use that flow direction to look at flow accumulation, start from high areas and work downstream, accumulating the number of cells that drain into each cell, or the area that drains into each cell. So you get this raster that has 0 cells, like some cells get no contribution to the cell that has the largest number. This really large number, it drains everything. So we'll classify this again to see where potential streams are. We're using 3 thresholds, 10,000, 25,000, 50,000 cells. And the small areas will give no color, and then where putative streams are, we'll give other colors. Now I'm changing the display here so we can see where these putative streams are, and these other colors are ranges of blue from the light blue down to the dark blue to show stream location. We'll go with the 50,000 here in our example, but you'd really want to go out in the field and get an idea of approximately what threshold leads to a stream as you define it on the ground. Again, we use 50,000 because it seems reasonable, but you'd really want a better selection threshold. So after we've done the flow accumulation, we want to snap the pour points. We want to get an outlet for our watershed. We have to create then a new shapefile and digitize the pour point into that shapefile. We won't show all the steps here because you know how to digitize, or you should. So we'll go to near where we want our outlet using the location of the stream, the approximate location, to get our digitized point, as shown here. Now it's not exactly on the stream, that's why we do the snap pour point. So we'll snap to the flow accumulation, and we have to set a snap distance. We don't want the snap distance to be too big for our new outlet, so we don't want to move it too much, but we want it to be big enough so we can actually find the nearby stream. And so after we run it and recolor it, we can see this new raster snaps onto those stream locations. So now then we'll do the watershed once we have our snapped outlet. We'll specify that snapped outlet in our flow direction layer and run the watershed tool, and it'll give us then a raster that's colored with the watershed value. Here, recoloring it so we can see the display. We'll set the display here to some semi-transparency, and you have your watershed.